Welcome to Serious Talk, Agentic AI. I'm Greg Banks. Today I'm joined by Tim Harding and Gavin Franklin, and we're getting practical. What it really takes to build a custom AI agent end to end when off-the-shelf platforms don't fit your use case. In this episode, you'll walk away with a clear picture of core architectural layers from user interaction to back-end execution. 6 key decisions you must make to go custom without overcomplicating it, and a real-world example of cross-system agent including hosting, memory, RAG monitoring, and LLM choices. Thanks for spending time with us. Let's dive in. All right. Sometimes AI conversations feel a little bit like a bowl of alphabet soup. LLM, RAG, MCP. A house is no better than the foundation it's built on. You have to start right if you want that house to stand. Same's true for AI agents. I really look forward to today's conversation. Gavin has created another artifact for us to look at. We're going to really drill into some of the core architecture decisions for a custom AI agent. Tim and Gavin, welcome back, guys. Let's dive into this one. This is a good topic.
Yeah, looking forward to it. Should be a good one. And yeah, a little bit of overlap with some other topics that we've had, but really trying to pull the topic today of really what does it take to create a custom AI agent end to end and really try to boil it down into a clear picture for people to kind of understand all the different aspects that they got to consider to actually roll a custom AI agent out to their business. Obviously, everybody's familiar with platforms like Agentforce or Lindy or Crew AI or you name it, right? And there's a lot of platforms out there that take care of a lot of this for you. But I think a lot of businesses are really trying to understand, okay, well, what if these aren't doing exactly what I need it to, and I really need to go and build something custom? And again, we looked at costs a few weeks ago of the cost of custom versus a platform, and sometimes cost too can be pretty straightforward. So you really got to determine this case by case basis. But coming back to it is we really kind of want to look end to end. What does it take to actually do this? There's a lot of things to pull together here. So really excited, Gavin, to kind of chat with you on this. And I guess where do you want to start? Kind of what are kind of big picture? What a business got to look at if they say, okay, we've looked at some other options here. It's not doing what we need to. We want to roll this custom AI agent out across our business. Everybody's getting value from agents. We want to jump on the bandwagon here. Where do they start?
Yeah, so just up front, if we think from a company's perspective, if you get into the area where you're investigating AI agents, you've looked at your platforms and their agent offerings and found that you need something a little bit more comprehensive of your entire systems. You want something tailored to your specific use cases. That's moving away from architectures that are already pre-existing, right? Things like Agentforce that is hosted and built within the Salesforce platform. So what is that going to take to build an AI agent that is able to communicate across all of your systems and to take actions for you? So from a tech stack perspective, I would like to take this journey through interaction through backend. So the first thing you're going to want to look at is how is your end users interacting with your agent? So that means you need some sort of application or user interface. There's quite a few different ways this can be handled. Maybe you're interacting with your agent through Slack or comms applications. Maybe you're interacting through an agent through applications that your users work in. So you can build something in Salesforce that's not Agentforce that interacts with your backend agents. Maybe it's an agent that doesn't need a front end at all, and you just want it working on it behind the scenes, attempting to facilitate something, but you need to call it through APIs. So that's the first layer. Where it lives is 100% up to you, and that's going to be something that you're going to have to make edits to, whether it's the application you want it to exist in, it's your website, all kinds of different options for that. The alternative is you can also host that user interface on some endpoint that you create. If you go down this route, you're going to have to leverage some cloud hosting tools. So if you want, you can always put your user interface up there to provide a different avenue for your users to.
Yeah, no, I think I definitely agree with that. And I think like one of the things we're seeing and one of the things we're kind of predicting as well is that Slack, Teams, Discord, really natural areas to kind of throw an AI agent. So don't assume that you have to go build this custom UI where people actually live in today. A vast majority of enterprise and business teams today are already living in Slack, Teams, and Discord. So meet users where they're at and really look at going custom or into another system specifically if for whatever reason, you're not using one of those three. So for a lot of customers we'll work with, that typically is like the starting point. But yeah, where do we go from there?
Yeah, I think the next thing you need to start looking at is where are you going to host the actual logic of the agent itself. So there's a bunch of tools that the agent is tied to as well. Things like MCP services, RAG pipelines to get your documents, things that we've discussed in some previous episodes, as well as applications that can monitor your agent and provide feedback on how your agent's operating and the cost that it's accruing. All of that would need to live in some sort of framework. I would suggest looking at cloud hosted architecture first. So tools like AWS, Google Cloud Platform, pretty much anything that allows you to host endpoints. So your front end user application is going to take those prompts that the users are creating and send it to your hosted AI agent living on your cloud-based framework.
Yeah, I think a lot, same thing, kind of similar principle here. Vast majority of businesses are already on Google Cloud, AWS, or Azure in some way, shape, or form. So you don't have to go find a whole new place to like host this application. It's similar to hosting other cloud-based applications as well. So a lot of times you can kind of look at your existing architecture and see if it'll work for you there.
Yeah, and depending on the maturity, the technical maturity of your company, you may already have tools like ETL tools like MuleSoft or Delboomi hooked into your server or your server architecture. So you can look to extend out API functionalities by putting these on those hosted services and then establishing ETL endpoints for those. So definitely ways that you really just need to treat all of these tools and the agent itself as a service that you're providing your front end to be able to hit and allow it to manipulate your back end, which is really the next part of the story. So when you're talking about things like memory and knowledge articles, right? So anything that you need for documents in your system, that's really going to be your back end, particularly with agent memory. We're seeing tools hit the market more recently for the RAG pipeline that depending on the system in which you're storing your documents, they actually already have built-in vectorized capabilities. So we'll cover that in an example here in a second. But this is typically where you want to look at another platform for agent memory or documents that you're going to need to give your model context.
Yeah, I think some examples here, again, if you're on like Google Cloud or Amazon Web Services, they're starting to have kind of end-to-end services that handles this as well, so you can stay within one platform. But then there's also other options that are out there. One of the most popular ones right now has been Supabase, where you can kind of get back-end database functionality, and they're really trying to gear themselves towards a lot of these use cases. So you have some decisions to make there, but a lot of different options. And again, something might exist in your current architecture.
The last thing I would look into as well is what are you choosing as an LLM and what are the pathways you're going to go about that? So there's really two different models in which you can approach LLMs. You can do a self-hosted LLM or you could do API-based LLMs. Both of them are going to cost you just in different ways, right? One is going to cost you the runtime of wherever you're hosting the LLM. They're going to need GPUs and they're probably going to need to be running for a majority of uptime. The other option is the API calls. So that's just like connecting a Anthropic account or Chat OpenAI account. So those are just going to charge you just based off of their pricing models for API calls, right? So just another piece of the tech stack that you're going to have to decide how you want to go about it, whether or not you want to go self-hosting or those API calls. And we're really going to have to factor in the cost of both of those.
Yep, absolutely. And also though, I think is people think like, okay, I got to choose one LLM for my whole agent architecture, and once I pick that, then I'm kind of locked in. But I think what we've really been trying to convey over the last several episodes and move forward, and what we're seeing with a lot of clients as well, is you really want to determine this at the agent level as well. And you can work with multiple LLMs across your architecture and still kind of have a clean overall multi-agent architecture. You really want to align that on the use case specifically. So then I think that kind of leads then to kind of tools and then monitoring. So I think monitoring is something that a lot of people don't really cover here. I think we're going to cover kind of security and monitoring here in one of our next couple episodes. But like, what do they got to look at in terms of monitoring?
Yeah, so for monitoring, there are a few different ways you can go about it, right? So if you have your self-hosted architecture, you could do things like monitoring your CPU runtimes, monitoring the prompts that come in. So there's a monitoring at a level of what you can actually code into the agent architecture itself. So that'll give you a good idea of how much agent is costing you, what tools it's utilizing, how users are interacting with it, how often users are interacting with it. And then there's also monitoring in terms of improvements to the agent. So there's a lot of tools that are available on the market today, like Langsmith is probably the most common one when you look at the various different frameworks. That one is really used to monitor the health of your agent, along with the various things we were just talking about from the usage of it. So yeah, oftentimes you'll either look at a third-party tool to do that, or you'll look at hosting that application in your platform, just like you would an agent or a tool.
Yep, absolutely. And so I think kind of overall, we're covering kind of the core decisions you're going to have to make. But just kind of know going into this, there's really kind of 6 core decisions that you really have to make in terms of a tech stack when you're going to go host an agent and build it out fully custom. Could be more, right? Depends on, if you want to add additional tooling, how many MCP connectors, et cetera, what the scale is of what you're building. But at a minimum, you're kind of looking at these 6 kind of core decisions to look at for rolling out an AI agent. And maybe it'd be helpful, like, let's give an actual business example or a vignette and walk through what it could potentially look like. And so I think we had one example to share, Gavin, to kind of walk through, like, what could this actually look like end to end for a potential build out.
Yeah, absolutely. So let's say one of your core platforms is Salesforce, and you have a ticketing system in Zendesk. So users can go and submit technical issues that they're experiencing in their systems into a Zendesk ticket. And this agent concept is somebody or an agent that's monitoring those incoming tickets, attempting to triage those tickets, potentially attempting to solve the problem in Salesforce, depending on the complexity, and then giving reports back and updates to the Zendesk ticket itself. So it's communicating to both the user that's submitting the ticket, it's communicating to the user that might be working on the ticket. So what this looks like is you're going to have some sort of interface with the agent in Zendesk potentially. So this is an example of an agent that can monitor without a user interface. But if you wanted to ask the agent to work on a specific ticket, or you wanted to get feedback on why the agent did something that they did in a ticket, you would have to build out some sort of platform or some sort of application within Zendesk to allow the communication and the call outs to your custom agent. The next layer you're going to hit is that actual AI agent platform. So in this example, we have this hosted in Google Cloud Platform. So your Zendesk front end is going to communicate with your Google Cloud Platform endpoint. And then from there, everything that's in the Google Cloud Platform are things like your MCP tools. So in this example, you have 2 MCP tools that the agent has access to. One is to interface with Supabase. That's actually an out-of-the-box MCP service. So when you're deciding on what tools to utilize for MCPs, some of them already exist on the market and are open source. Some of them are ones that you might need to build custom. So in this instance, there's a custom MCP service to Zendesk and an out-of-the-box MCP service to Salesforce. So those are 2 different options you could think about as well when it comes to tools. Additionally, it's going to leverage Gemini's LLMs, right? So this is just an example. LLMs, like Tim was saying earlier, something that are pretty easy to change out and can be agent to agent specific. So in this use case, we're going to leverage Gemini LLM through API calls. So that's a separate service. And then all of your documents for how your Salesforce is architected, your typical service responses, examples are going to be in, let's say it's in a Google Drive. So you're leveraging Vertex AI Search, which is a Google product now on top of their Google Drive that does exactly what we've been talking about with the RAG pipeline. And that allows you to access your documents and gives your AI agent, context to how you typically operate from your document standpoint. Your agent memory is going to be stored in Supabase. So this is an example of you need some sort of a relational database that can be accessed via SQL for your agent to pull freely from historical memory context of how a user is interacting with it. So your agent memory is going to be logged into Supabase. And then you're going to use Langsmith for monitoring your AI agent health, how often it's being utilized, the interactions it has with your users. All of those things are going to be captured within Langsmith. So just going at a high level, what that tech stack looks like and what's going to cost you money in the long, right? So you have a UI interface in Zendesk, right? So that's going to have to be built. You have your Google Cloud Platform, which is going to run all of these containers. That's going to cost you money as the agent is being utilized. You're going to be paying for those CPU times. You have your custom agent itself. This is a one-time build, but it can always be iterated on. You have your Salesforce MCP and your Zendesk ACP. Those are all things that can be built one time as well, that again can be iterated on. You've got your Gemini LLM key. That's going to cost you money every time the agent is used. Your Supabase account, that is a monthly cost as well, just like Zendesk or Salesforce. It's a platform cost. Your Google Drive with Vertex AI. So every time you get documents that get chunked and vectorized, all that is going to cost as well in order to provide that input to your agents. Langsmith for monitoring, which is a platform that's going to have a monthly cost, and then Salesforce. So big tech stack for this relatively simple process of trying to execute on, tickets coming in and solve it on the platform and report it back to users. But a lot of that is already baked into your architecture.
Yeah. And I think it's the classic kind of give and take in terms of I gain flexibility and then I have added complexity though. So it's really hard to kind of keep simplicity in terms of building architecture complexity as well, with that customization. So it's really just kind of a balancing act in terms of what you're prioritizing there. There's many use cases where this makes a lot of sense to go custom and build it out to really have full control over the levers of how you want this agent to act and operate. I think one other thing that was kind of I wanted to highlight here is kind of talked about like one front end, but you're really not limited to one front end either. I mean, I think this is one of the kind of unheralded advantages of AI agents too, is that it's really easy to expose this in multiple front ends because we have really strong protocols of how to interact between systems. And so if you want to put it in Slack and Zendesk, right? So you can have the same agent exposed in multiple places. Or if I want to have the same agent exposed in Zendesk and Salesforce, right? So don't think like you're limited to just having one spot for this agent as well. I think this is one of the biggest advantages of like AI agents versus kind of the old legacy kind of chatbot models or even workflow automations, is now we can put a lot of time into building the brain, the decision piece, this agent here, and expose it in multiple areas in terms of multiple front ends and really get a big bang for your buck in terms of the effort you put into it as well. But anyways, really solid takeaways here. I think kind of what we laid out here is should give you, like, if you're just uncertain kind of where to start with a custom AI agent, like this is kind of a pretty good overview in terms of the big components you got to make decisions around. The example tech stack that Gavin kind of went through, pretty common tech stack that you're going to see across a lot of enterprises that are building custom agents today. So I think that's pretty representative of what a lot of businesses are doing that are going the custom AI agent route. So if you're like, I have no idea where to start, they should give you a pretty good idea in terms of big muscle movement pieces that you got to keep in mind to build out in architecture. So yeah, great conversation. Look forward to continue to unpack this even more. I think over the next few weeks, we'll be looking at kind of, security. How do you, enforce and ensure security with your AI agent architecture? How about multi-tenants as well? Like if you've got multiple tenant organizations, potentially customers, right, using the same AI agents, how do you keep their data isolated and siloed between those? So this was a really good kind of jumping in point as we do a deep dive into some of those topics. So thank you, Gavin.
Absolutely.
Yeah. Thanks, guys. Appreciate it. Good stuff today.
Have a good one.
Well, that wraps today's episode of Serious Talk Agentic AI. If this helped clarify what it takes to build a custom agent, please take a second to follow or subscribe wherever you listen. And if you're enjoying this series, please leave us a review. It genuinely helps more leaders and builders find the show. And one more ask, share this episode with a business leader or a technical team that's struggling to move from AI experimentation to real implementation. If you're trying to decide between platforms and going custom, this is exactly the kind of architectural clarity that can save weeks of rework. We've included links and resources in the show notes, including recommended content connected to today's discussion. And if you've got questions or want to talk through your use case, reach out to us anytime at serioustalk@serioussolutions.com. Thanks again for listening, and a special thank you to Jason Fowler for allowing us to use his song, Mystery Road. See you next time.